Hello students, let us continue the session on trigonometry. In today's session, we will learn some important applications of trigonometry. One of the main applications of trigonometry is to find the distance between two or more than two places, or to find the heights of the object or angle subtended by the object at the given point without actually measuring the distance or the height or the angle. Trigonometry is useful to astronomers, navigators, architects and surveyors, etc. in solving problems related to heights and distances. Heights and distance. The direction of the objects can be described by measuring two important topics called as angle of elevation and angle of depression. Angle of elevation or angle of depression of the object are measured by an instrument called as theodolite. The theodolite is based on the principles of trigonometry, which is used for measuring the angles with a rotating telescope. In 1856, Sir George Everest first used a giant theodolite, which is now on display in the Museum of the Survey of India in Dehradun. Here you can see the image of theodolite. It has got a rotating telescope. Using this, angles are found. Angles are measured. What type of angles are measured? There are two important types of angles. One is angle of elevation, other is angle of depression. Look at this figure. Here you can see I. If an object is placed over here, the person is seeing the object which is there on the wall. There is a straight line which is connecting the object and the eye. It is called as a line of sight. And there is an angle which is found between the horizontal line and the object. It is called as angle of elevation. If I name this point as P, the position of the object, let P be the position of the object above the horizontal line OA, and OB the eye of the observer. The angle formed AOP is called angle of elevation. It is called angle of elevation because the observer has to elevate or raise his line of sight from horizontal OA to see the object P. When the eye turns upwards above the horizontal line, we get the angle of elevation. Line of sight is a line drawn from eye of an observer to the object viewed. This is the situation when the object is above the horizontal. In some situations, we get the objects which is below the horizontal. Look at this figure. Here, if an observer is viewing the object here, if the object is placed at point P, let P be the position of the object below the horizontal line OA, and OE is eye of the observer. Then the angle formed AOP, if this particular point is O, the angle formed AOP is called angle of depression. It is called the angle of depression because the observer has to depress or lower his line of sight from horizontal OA to see the object P. Below the eye level, if the object lies below the horizontal plane of our eyes, then we have to move our head downwards to view it. In doing so, our line of sight moves towards downwards through an angle, and the angle which the line of sight now makes with the horizontal line is called angle of depression of the object from our eyes. Have a look at this example. Let OH be horizontal line at eye level. If a person at O looks the object P lying below the eye level, then HOP is the angle of depression of point P as seen from O. Here is the point O, observer, and this is a horizontal line, this is the line of sight. If you revert the situation, if the person is there at point P, it becomes the observer, and if he is observing the point at lighthouse, the angle found between horizontal and the line of sight will be the angle of elevation. This becomes elevation, the angle of elevation. You need to note that the angle of elevation of point P as seen from point O will be equal to angle of elevation of point O as seen from point P. Here, angle of elevation and angle of depression, they are alternate interior angles. So, those two angles will be equal to each other. Is that clear? There are certain important points you must remember in solving questions related to heights and distances. The first important point is, in solving problems, observer is represented by a point of his height is not given. If his height is not given, the observer is represented as a point. The next important point is, in solving problems, object is represented by a line segment and sometimes by a point if the height or the length is not considered. I'll give an example. Look at this. AB represents the tower. Point C is an observer. The height of the observer is not given, hence only the point is considered as an observer. A line drawn parallel to Earth's surface is called horizontal line. The angle of elevation and the depression are always acute angles. Look at this. There is a tower. Here there are two people, say they are represented with the points A and B. If they are observing the top of the tower, the angle of elevation is 60 degree as well as 30 degree. If you consider a person to be standing over the tower, and if he is seeing two ships at point A, point B, these two angles, angle from point B and angle with respect to point A, ship A and ship B, they are acute angles. Because these two angles, they are less than 90 degree, so they are acute. If the observer moves towards the objects like tower, building, cliff, etc., the angle of elevation increases, and if the observer moves away from the object, the angle of elevation decreases. Let me explain this through this figure. Here, the sun is represented using this figure. If the observer moves towards, then the angle of elevation increases. If he moves away, the angle of elevation decreases. The next important point, if the angle of elevation of the sun decreases, the length of the shadow of an object increases, and vice versa. If in problems, the angle of elevation of an object is given, then we conclude that the object is at higher altitude than observer. The angle of depression implies that the observer is at higher altitude than the object. With these key points, let us try solving exercise 9.1 questions. First question is, a circus artist is climbing a 20-meter rope which is tightly stretched and tied from the top of the vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. You can see figure 9.11. Here AC represents the rope and AB represents the pole. Let me mention that AB represents the pole and AC represents the rope. Here there is a right angle formed in triangle ABC. With respect to angle C, we have sine of 30 degree equal to opposite side, which is AB, upon hypotenuse, which is 20 meter, which is AC. Let me substitute. Sine of 30 degree is 1 upon 2, which is equal to AB upon AC. Instead of AC, I'll mention 20 meters. Now we can find the length of AB. The length of AB becomes 10 meter. Therefore, the height of the pole is 10 meter. Second question. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Here I have drawn a figure. Here AC represents the tree. Let me mention that. Let AC is the tree which breaks at B. The broken part AB becomes A dash B. This will be the broken part. Look at the triangle A dash BC. We have got the tan of the angle tan 30 degree is opposite side upon the adjacent side. Tan 30 degree is nothing but 1 upon root 3. This will be equal to the length of BC to be found divided by 8. Therefore, BC will be 8 upon root 3. This is the length of BC. Now to find the length of A dash B, I need to use another trigonometric ratio. Now I'll consider cos of 30 degree, which will be adjacent side A dash C upon the hypotenuse AB, A dash B. This implies cos 30 degree is root 3 upon 2. This will be equal to 8 upon A dash B. This implies A dash B is 16 upon root 3. Now with BC and A dash B, by adding I'll get the length of AC. Therefore, AC will be equal to BC plus A dash B. This will be equal to BC is 8 by root 3. A dash B is 16 by root 3. Upon adding, we get 24 by root 3. The same thing can be written as 24 into root 3 divided by 3. 3 8 times. So we get 8 root 3 meters as the height of the tree. Therefore, the height of the tree is AC, which is 8 root 3 meters. Question number 3. A contractor plans to install 2 slides for the children to play in the park. For the children below the age 5 years, she prefers to have a slide whose top is at 1.5 meter height and is inclined at an angle 30 degree to the ground. Whereas for the elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle 60 degree to the ground. What should be the length of the slide in each case? Here I have drawn 2 different figures. One is for children below 5 years. The angle inclined is 30 degree and the height of the slide is 1.5 meters. Another figure for elder children, the angle inclined is 60 degree and the height of the slide is 3 meter. Now we need to find the length of the slide in both these cases. In the first case, I'll mention this as for children below 5 years. I'll make use of a trigonometric ratio in which AB and AC are the parts. I'll get it by sine of the angle 30 degree. Sine 30 degree is opposite side upon the hypotenuse. Sine 30 is nothing but 1 upon 2. This will be equal to 1.5 by 2, 1.5 by AC. Therefore, the length of AC is 3 meters. For children above 5 years, again I'll make use of a sine 60 degree, which is AB upon AC. Sine 60 is nothing but root 3 upon 2. This will be equal to 3 meters divided by AC. So let's find AC. Therefore AC will be 6 by root 3. I can multiply root 3 by root 3. I get 2 times root 3. So 2 times root 3 meters is the length of the slide for elder children, and 3 meter is the length of slide for the children below 5 years. Question number 4. The angle of elevation of top of tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. Find the height of the tower. Here I have drawn a figure. This AB represents the tower. We need to find height of the tower. Point C is the point where the observer is there. He is making an angle of inclination of 30 degree and is 30 meters away from the tower. So in triangle ABC, we have tan of 30 degree equal to AB upon BC. Tan 30 degree is 1 upon root 3. AB we need to find, divided by the length of BC is 30 meters. Therefore, AB will be 30 upon root 3. I can multiply and divide by root 3 so that I get it as 10 times root 3 meters. Therefore, the height of the tower is 10 root 3 meters. Question number 5. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily fixed or tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string, assuming that there is no slack in the string. If there is no slack in the string, it becomes a straight line. It acts like hypotenuse. The kite is represented as K in this figure. Let K be kite, and P is the point where the string is tied on the ground. Let me represent another letter here, L. This triangle KLP, we have sine of 60 degree equal to KL upon KP. The length of KL is known, it is 60. Sine 60 degree is known, it's root 3 by 2. This will be equal to 60 upon KP. We need to find the length of KP. KP will become equal to 120 divided by root 3. If you multiply root 3 and divide by root 3, we get 120 root 3 upon 3. So 40 root 3 is the length of the string. Therefore, the length of the string is 40 root 3 meters. Question number 6. A 1.5 meter tall boy is standing at some distance from 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. Here I have drawn a figure. In this figure, let PQ be building, AS be a boy who is 1.5 meter tall. He moves from S to T towards building. Here PQ is a building which is 30 meter high. Therefore, the length of PR will become PQ minus RQ, which will be equal to 30 minus 1.5, which is 28.5 meters. Now, with this opposite side PR, I can find with respect to 30 degree and 60 degree the length of AB and BR. Once the length of AB and BR is known, we can find the length of AB, which is equal to ST. Let us consider tan of 30 degree. Tan of 30 degree is opposite side PR upon AR. Tan 30 degree, the value is 1 upon root 3. PR will be 28.5 divided by AR. This implies AR will be equal to, this 28.5 is same as 57 by 2. So I will write it as 57 by 2 multiplied to root 3. This is the length of AR. Now let me consider tan of 60 degree, which will be equal to PR upon BR. This implies tan 60 degree is just root 3. This is equal to, the length of PR is again 57 by 2 divided by the length BR. Let me find the length of BR. BR will be equal to 57 upon 2 root 3. This is same as 57 root 3 divided by 2. 3 times is 6. It is divisible by 3. 3 19 times and 3 2 times. We get 19 root 3 by 2. Therefore, the distance he walked, ST, will be equal to AB. This will be equal to AR minus BR. The length of AR is 57 root 3 by 2 minus 19 root 3 by 2. The difference is going to be 38 root 3 by 2. It is divisible, 38 is divisible by 2. We get it as 19 root 3. So 19 root 3 meters is the distance he walked towards the building. Let us solve one more question for today's session. From a point on the ground, the angle of elevation of bottom and the top of the transmission tower fixed at the top of 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. Here I have drawn a figure. In this figure, BC is the building which is 20 meters, AB is transmitter or transmission tower. This particular tower, the top and the bottom are viewed at the point D. So the angle of elevation is 45 degree and 60 degree for bottom and the top respectively. Observe in triangle BCD we have tan of 45 degree equal to BC upon CD. Tan 45 degree is 1. This will be equal to 20 divided by CD. Therefore, we get CD as 20. So CD is 20 meters. Now observe the triangle ACD. In this triangle, tan of 60 degree is AC upon CD. We have found the length of CD. Let's use that here. Tan 60 degree is root 3, which will be equal to AC upon 20. Therefore, the length of AC, we get it as 20 times root 3 meters. Here, AC is nothing but AB added to BC. This implies 20 root 3 will be equal to AB plus BC is 20. Therefore, AB will be 20 common root 3 minus 1 meters. This is the height of the transmission tower. With this question, I end today's session. In the next session, we shall solve the remaining questions of the exercise 9.1. Thank you.